Oh, good day, everyone. This is Chris back again with the Ancient Scholars. We talked a little bit about carbon and how we have to hybridize the s and the p orbitals of carbon to kind of get this molecular geometry that we see when we have bonding with carbon. And of course, all the angles are at 109.5 degrees. So we have these sp3 hybrids, and now we have a basic understanding of what goes on there. Let's just go ahead and talk about binding with carbon. So we know that carbon can have up to 4 different bonds, we call covalent bonds. And often carbon will bind with hydrogen or oxygen. And this is very convenient. I can attach hydrogens in different configurations, oxygens, or even different carbons, and I can make really long chains of what we call hydrocarbon molecules. And these hydrocarbons, hydrogen and carbon primarily, are really the basis of organic chemistry. This is the fundamental units of carbon-based chemistry, or organic chemistry. And there are 3 classifications, 3 major classifications of these hydrocarbon molecules. And these include the alkanes, the alkenes, and the alkynes. Okay? An alkane hydrocarbon is a hydrocarbon where all of the bonds are single covalent bonds. Okay? Single covalent. Pretty easy. Alkenes are hydrocarbons where I have at least one carbon-to-carbon double bond, where I have 2 covalent bonds in between the carbons, and then I have hydrogens. Okay, so alkane is all single, composed of all single bonds. Alkenes have at least one double bond, a carbon-carbon double bond is commonly what we see, and then the alkynes, and I'm sure you probably guessed it by now, are hydrocarbons where I have a carbon-to-carbon, primarily triple bond occurring, and then hydrogens that come off of that. So alkanes, single bonds; alkenes, at least one double bond; and alkynes, at least one triple bond. Okay, so the characteristic or classic alkane that I think of is really the fundamental hydrocarbon molecule, and that is a molecule called methane. Okay, it's CH4, so it's a carbon, and then there are 4 hydrogens covalently bonded to that. And of course, we know hydrogens have 1 electron, so basically what I have is I have a hydrogen, 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 and hydrogen, basically surrounding the carbon. And of course, the hydrogens have their duet met, they're happy. The carbon has its octet met, and it's happy. So what I'm going to do here is I'm just going to go ahead and show you that. So here we have our alkanes, single bonds, and I have the CH4 molecule, all single covalent bonds, carbon, hydrogen, CH4, or the methane molecule. Okay, the next characteristic molecule I want to talk about are the alkenes, and this is a double bond. And this is a molecule known as ethylene. It has the formula C2H4. So I have 2 carbons, and because it is an alkene, the 2 carbons are going to have a double covalent bond between them, and then hydrogens off of those carbons, and that is ethylene. That is ethylene molecule. So if you look at the green here, this is the alkenes, double bonds. I have a carbon-carbon double bond here, 2 covalent bonds, and then I have 2 hydrogens that come off of this carbon, 2 hydrogens that come off of that carbon there. Those are single bonds, and this is an ethylene molecule, C2H4. Okay? And then we have finally the alkynes. This involves a triple covalent bond. And a characteristic molecule that we run into with the alkynes would be the molecule acetylene, excuse me. And anybody who's done high school welding, or maybe does welding in college, or even for a career, you should be fairly familiar with this. This is the oxyacetylene torch. that we often weld with. This is the acetylene gas that we use in that. And we have two carbons again. But instead of a double bond, I have a triple covalent bond between the carbons, and then a hydrogen on one carbon, hydrogen on the other carbon. And I'll just go ahead and draw you a picture of that. So here are the alkynes, at least one triple bond. Here I have a carbon-carbon triple covalent bond, and then a single covalently bonded hydrogen on each side, and that is, of course, acetylene, or C2H2. Okay, so those are the three broad, basic classifications that we call hydrocarbons. This is all hydrogen and carbon at this point. The alkanes, the alkenes, and the alkynes. Okay, guys, hopefully that made sense, and as always, thanks for hanging in there.